learn graphing and solving quadratic equations, we need to learn some important features of the graph of a quadratic equation. In order to be able to do that, oftentimes we have to have, or we will have to have, our quadratic equation in standard form. And standard form is when the equation is set to y equals ax squared plus bx plus c. And a, b, and c are going to be numbers. So these, in your quadratic equations that you see, the a value, the letter b, and the letter c will always be changed to numbers. The only one that cannot be 0 is a, and that's what this says right here. A cannot be 0. If a is 0, then you won't even have a quadratic equation. You'll have a linear equation, and we'll be back into the first unit. At the beginning of this unit, you've been pretty much just trying to do what's called factoring and finding out what it is that gets multiplied together to give you these quadratic equations. From now on out, you will start with the quadratic equation in standard form, and you're going to be working on graphing them and solving them. Actually, you're going to be working on solving them, and graphing them is one way to solve them. But before we start doing the graphing, we need to learn the important features of the equation that will help us make the graph and actually help us determine some important points on the graph. So first off, we want to look at the value of a in the quadratic equation. The value of a determines if the graph is going to open up or down. Okay, it's the a value that does that. So this number that's right here in front of the x squared, that is always going to tell for you whether or not the graph is going to open up or down. The way you decide is by what is its value. If the value of a is greater than 0, the graph will open up. And the one nice feature about the graph of a quadratic equation is that it's always U-shaped. So when I say that it opens up, then I mean it's going to be a U-shaped, it's called a parabola in technical math terms. It's going to be a U-shape that opens up. If the value of a is less than 0, the graph is going to open down. So for instance, maybe something like this. Okay, now I just put some random graphs on there, but I know that when I look at an equation, I can determine if the graph is going to open up or down just by looking at the number that's in the front of the x squared. If it's positive, the graph opens up. If it's negative, the graph opens down, and you might, feel better writing positive a value, and then over here with the purple graph, negative a value. Okay? Because this graph is U-shaped, like it is, the graph is going to be what's called symmetrical. In other words, there's going to be an imaginary line that goes down the center that divides the graph into two parts. And what you see on the left side of that imaginary line is going to line up perfectly with what you see on the right side of that imaginary line. Now, if we can find our imaginary line, then we can use that idea of symmetry. That's what that word is right there that I underlined in green. We can use that idea of symmetry to help us draw and copy half of the graph. How we find out what that axis of symmetry is by using this formula right here. And you're going to want to get that formula in your notes. X equals the opposite of B over 2 times A. If you're not sure how to read that, X equals opposite of B divided by, I use the word over because we may not actually divide it out, over 2 times A. Now where did the B and the A come from? The B and the A come from back up here in this equation. The b is the number in front of the x term, and the a is the number in front of the x squared term. We're always going to have an a value. Sometimes our b value might be 0. If we don't have that middle x term in our equation, then the b value is going to be a 0. Okay, we'll do an example together here in a little bit. Another important feature of what's called a parabola, or the graph of a quadratic equation, is the fact that it has a high point or a low point. If the graph opens up, the graph that opens up has a maximum, or I'm sorry, has a minimum point. I'm sorry, it's a minimum point. If you look at the blue graph that I have up top, I'm going to guess maybe like right about here. Let me get a little thicker marker. Like maybe right about here would be the minimum point, the lowest point on the graph. And a graph that opens down has a maximum point, a high point, the highest point on the graph. If we can find that point, then that's going to help us kind of know or give us some information about our graph and how high to graph it. We don't want to go anything above that or anything below that. Graph opening down has a maximum point, a high point to its graph. Okay, so there's a lot of notes right there that I hope that you were able to get down, because now we're going to work on an example and what this is going to look like. Let's see, I'll keep them there and maybe flash them up at the end of the video if I remember, so that you can get back to it if you had missed something. So let's say we have the equation y equals x squared plus x minus 6. Okay, and we want to be able to find some key features for this graph in order for us to help to graph it on the coordinate plane. First thing that you want to do is identify what are those a, b, and c values. Now, in case you don't remember from your notes, a is the number in front of x squared, b is the number in front of the x term, and c is the constant down here at the end. Sometimes these numbers might be positives and sometimes negatives. It can be, it can be a combination of the two. So the number in front of the x squared term is a 1. There's no number there, so we expect it to be a 1. The number in front of the x term is also a 1. And the constant happens to be a negative 6, because the number that's in that place is a negative 6. That will come in handy here in a minute as we're starting to graph these. I didn't talk about it on the first sheet of notes. I ran out of room, but it'll be easier to see once we actually get it on the graph. Okay, so now that we know those values, we can start to determine some things about our graph. One of the things that I mentioned in the notes is that we can decide right now if this graph is going to open up or if it's going to open down, just like by looking at the a value. Since a equals 1, which is positive, the graph will open up. So my U shape, it's going to look like a U, not an upside down U. So I know that it's going to be something like this, let's just say, for example. Okay, now I can also determine what my axis of symmetry is going to be. Okay, axis of symmetry had a formula. And the axis of symmetry is a line. So that's why, and in parabolas, it's always going to be a vertical line, a line that's going up and down every single time. And that's why the equation for the axis of symmetry starts with x equals, and then this is going to be a number over here, the number that we're going to calculate based on the a and b value from the original quadratic equation. If you have a parabola that's opening up or down and it's U-shaped, The axis of symmetry, in order for it to go through the center, is going to have to be a vertical line. Horizontal lines wouldn't go in the same direction that a parabola does. So in our example, again, we have b is 1. So it's going to be the opposite of 1 over 2 times a. Well, since our a value is a 1, we get the equation for the axis of symmetry to be at -1/2. Okay, so now does this graph have a maximum point, a high point, or does this graph have a minimum? Now this is what confuses people sometimes. Because a is positive, people will often think that it has to have a maximum point. But since a is positive, that's causing the graph to open up, which is going to cause it to have a minimum point. Okay, so we're going to have a minimum point in this graph. And the way that we're going to find that minimum point is by use x equals -1/2 to find a y value. Whoops, a y value that will go with that. The way that we're going to do that, now I don't know, I don't have much space here, but we're going to give it a try. Y equals x squared. Well, for our lowest point, x has to be -1/2. Our maximum and minimum points always have to lie right on the axis of symmetry, because the maximum and minimum point is going to be in the middle. It's going to be the place where that U-shaped either reaches its highest or lowest point. And the only place that it could do that would be right in the middle of the graph. And you'll see that in a little bit when we start to graph this. So -1/2 plus -1/2, because that's another place for x. So wherever I see an x in the equation, I'm changing it to -1/2 just long enough so that I can find out the other part of my minimum point. So -1/2 squared is going to be a +1/4. And then I've got plus a -1/2. Whoops. And then here I'm going to put plus -6. So 1/4 plus -1/2 is -1/4. -1/4 plus -6 is going to equal -6 1/4. So the place where my minimum point is going to be located is at -1/2, -6 1/4. I'm sorry, I wrote a half here, but I think I said 1/4. Whoops. Apparently it doesn't want to select just that little bit. Okay, so 1/4. -1/2, -6 1/4. Okay, so now I have some of the features that I'm going to need to start to be able to get to draw this graph. Okay, so I'm going to say that this is going to be a 1, -1, -2, -3, 1, 2, 3. And then I'm going to go by ones, possibly go by ones up here. I won't be able to do that. I'm going to have to go by 2s because I got to get down to all the way down to -6 1/4 because of where my minimum point is located. Okay. All right, my axis of symmetry is at x equals -1/2. So I know that halfway between here, and yours will be straighter because you'll be able to use rulers or something as a straight edge. A lot of times the side of your planner cover works really good as a straight edge. It's pretty heavy plastic. It'll allow you to draw a straighter line. I'm not able to put a ruler on here to be able to do this. So I know that that's where the axis of symmetry is going to be. That's the middle of my graph. My lowest point on the graph is going to be located at -1/2, -6 1/4. So this is 7. I'm going to have to go pretty close to here. And that might be a little bit overkill with the size of that. And we'll make it blue so we can see it better. So -6 1/4 might be maybe right about here. Okay, the blue would be, or the thicker one would be better. It's a little bit too big. Okay, so that's my lowest point on the graph. Now I need to get this to be U-shaped, so I have to find some other points on my graph. One easy number to plug in and try is going to be 0. What if x is 0? Well, if x is 0, that's going to cause these first two terms to both be 0, because you're going to have y equals 0 squared plus 0 minus 6. This is a another very important part of your graph, and it's going to be called the y-intercept. The y-intercept, of course, is the place where the parabola is going to cross the y-axis. Because it has to cross the y-axis along here where x is 0, then you're going to plug 0 in for each of these points. Now when I'm doing that, I kind of like to cover them up with my finger, but what I did is I just put a blue dot over top of them for now, and basically that tells you, your constant tells you what your y-intercept is going to be. So your constant value is your y-intercept, and you may even want to include that in your notes. I've kind of run out of space to do that. C is the y-intercept every single time. Okay, C is the y-intercept. So at 0, -6, really close here, I'm going to have another dot. Now here's the idea of symmetry. If I have a dot a half a unit away from my axis of symmetry, so this dot right here that I've got my pen hovering over is 1/2 of a unit away from the axis of symmetry on the right side. Then I know on the left side of that red line, the axis of symmetry, I'm going to have another dot 6 units down, just as far away, because of the idea of symmetry. Remember, I need to have the right side of this graph look the same thing as the left side of this graph. Now I need to get some other points on this line. And I do that by plugging numbers in. As a class, we'll investigate what happens on the graphing calculator too. This is pretty easy to do on the graphing calculator, and we'll take a look at that together. So what if x is 1? Y equals 1 squared Okay, what I wanted to do is take those dots off of the equation. Should have done it a while ago. That way now when I plug my other numbers in, I can see the math that I'm doing. So if x is 1, 1 squared plus 1 minus 6. That's going to be 1 plus 1, which is 2. 2 minus 6 is -4. So I'm going to have a point at 1, -4, because I plugged 1 in for x. The answer that I got was -4. That's what's going to help me get another point on this graph. And actually, it's going to help me get 2 points on the graph. So at 1, -4, I'm going to have a point. Now that is 1.5 whole units away from the axis of symmetry on the right side. So then I know that I need to go 1.5 units away on the left, and I'll have another point that's -4. So here's a half, here's a whole, and I'm going to put a dot right there. So you might be, starting to see that symmetry come in. Okay, the next point I'm going to try is, I guess, a 2. I like to be able to use easy numbers to work with, and let's get this work out of the middle. So I'm working with limited space. And so now I'm going to try x equals 2. So y equals 2 squared plus 2 minus 6. 2 squared is 4. 4 plus 2 minus 6 is going to be 6 minus 6, which is 0. So when x is 2, y is 0. So that point's going to go right here. When we get into graphing to solve quadratic equations, this kind of point, which is called the x-intercept, is going to be very helpful in your solutions for graphing these quadratic equations. And now also, because I'm 2.5 units away from the axis of symmetry on the right, I want to go 2.5 units away on the left. So here's a half, 1, 2, and then I have another dot to go with it. So the nice thing about symmetry is I really only have to draw half of the line because I can use symmetry to come up with the other side of the line. Makes it very, I guess you'd say less work. I don't know why it doesn't want to erase this part. Oh, because it got hooked to. Well, we're going to take it out. I'll just put maximum or minimum back on here. Okay, now at this point, I'd like to say that for your graphs, you should have at least 5 points to make it. And because we're getting into kind of a longer amount of time here, I want to get this graph drawn in. So I want to use a color where you'll be able to see. I'll try this purple. And what you want to do is get this to be as smooth of a curve as you possibly can. With yours, you'll be able to erase, use your pencil, and like right here, I got a little bit flat. So you want it to be kind of a smooth curve. Okay? And that's the graph of a parabola.